and I'm going to show you a little bit on MIG. Now, TIG welding, tungsten inert gas, so I've got a tungsten electrode. Essentially, if I've got my ground wire here, when he steps on the pedal, he's creating a current. He can add, different amounts of heat by his foot control and different amounts of metal by how much he feeds that wire in. Well, a MIG is nice because it's more hands-free. I can do it one-handed, but I don't have as much control over heat and wire feed, because as soon as I press that trigger, I've got the preset amount of amperage and the wire's coming out to a preset amount of feed. But it's great because it can do a lot of work. It can do a lot of work that TIG welding can do, and they're more affordable. They're easier to get access to. So we're going to show you some of the things you can do with a MIG welder at home, like doing sheet metal and patch panels. Now here's a good example of what could be a patch panel, or in this case, a door strike. Hey, welcome back. Now here's the inner workings of a MIG welder. We got a spool of wire. We can do aluminum, but we'll need to get an extra driver on the other end of my gun. But for now, we'll look at just the steel. We can do different gauges depending on the thickness of the material and what we're going to be welding on. Now I've got a little electric motor in here that's going to drive this wire, through my nozzle, as well as put the shielding gas through. Now, most welders, typically if you flip the lid up, will have some sort of a chart to get you started. So if you're not sure where to begin, this will be a good place to start, and then you can dial from there. Now if we look at the front here, you can see, we've got our feed and we've got our temperature settings, so we can play with those independently. Once that trigger's set, that's what it's going to do. Now, here's this good application here, our door strike, and we're going to show you a couple of tips. Now, you can see I've got a couple spots in here, and sometimes those are the hardest to get started. And what I mean is, typically as the material gets thicker, I'll add more amperage. When it gets thinner, I'll reduce it. But sheet metal's so thin, if I go by that normal gauge, of temperature, I'm either going to have a cold weld that doesn't penetrate, or if I turn up my amperage, I'm going to burn a hole through it. So kind of a good tip for thin sheet metal is add amperage, but add some feed too. Now that extra wire going in is going to absorb some of that heat, so it doesn't all go into your panel and burn a hole. And what I like to think about is almost, you're giving it a good squeeze and release, is I'm actually taking a nice blob of hot metal and I'm going to push it in, so I got good penetration. I put a lot of heat into that thing and get it to, get in there and grab, so I've got good penetration of the metal, but I haven't burned through, and I've got plenty of metal there to actually make that joint. So if you can get your first wave of spots, after that it's a little bit easier, because you can see some of this metal is a little bit thinned out and rough from age and rust. Now the next pass, you can come in here. Now here's a weld, looks a little bit cold. I got my heat up. The next one, to get myself dialed in, it's penetrating a little bit better. This one's sitting nice and flat. The second pass, I can come back and I can overlap. So I can put my next weld halfway onto this one and onto my parent material. So once my first weld is in there from the first pass, the next ones I've got mass there to start my weld on, so I'm not burning a hole through my thin sheet metal.
Yeah, which is good, but on the bad side of that is that you're actually adding more material, which in effect you're making more of a heat sink and changing your heat setting just as you add more material. And the way we kind of counteract that is, one good idea is just to go back in and clean with a wire brush, and that will really kind of clean some of the MIG oxidation out of the way. But another good idea, take a little grinder, like a little hard wheel or a little grinding disc, and once you're kind of starting to fill in some of your areas, come back, knock some of those back off. What you're doing is taking rid of that material, so you don't end up with this big blob of not only dirt and contamination, but you're also keeping your heat setting consistent, because welding really is all about your heat setting.
Right.
It's all about the heat setting. Let me say it again. It's all about the heat setting. You know what I mean? It's a great thing about TIG. You can vary it as you're going.
Exactly.
And MIG, really take the time, get it set up right, get it good and flat, like you said. Once you get it to that point, you'll really be off and running.
Yeah, you don't have the dynamic control on a MIG, but with a little bit of patience, you can keep yourself consistent so your welds come out sharp, perfect every time. So I'm going to clip off any excess here on my wire, and I'm ready to come in here and start laying more tack welds around this thing.